number set, we have natural number 1, 2, 3, 4, 5. We have whole number 0, 1, 2, 3, 4, right? And then we have integer. We have this integer. And as I mentioned to you, these three set for natural number, whole number, and the integer number, these three set actually are of the same size. Three are the same size. Okay, because if you using the comparison rule, there's a 1-by-1 mapping. And then there's a rational number, a rational algebraic number, and the real number. Real number may have your rational number. Okay, so that's what we are covering, going to cover right now. And then eventually there's an imaginary number that's more complicated. So the number set and Venn diagram is like this. You have natural number that contained by whole number contained by integer number. But if you really compare the size of the set is actually the same. Then we have rational number, real number, and irrational number. So first, let's look at the real number. Real number in computer, actually, we cannot do continuous, but we try to mimic it. So we have this, people call it a scientific notation. So scientific notation means you have a fractional number in the front, and then you have some sort of the exponential term over here. That's called scientific notation. So you usually have 1.323, and then to the 10 to the power something 6 or something. That's called scientific notation. Are you okay with this scientific notation? Any question about this scientific? Are you okay? Feel comfortable or no?
Yeah.
This actually will be taught in your science. Okay, your science class actually like 8th grade science or 7th grade science should cover this. Okay, should cover this scientific notation. So scientific notation actually, as I mentioned, floating point number actually is like I have 3.25. I multiply by 10. I move the decimal point this way. If I multiply by divided by 10, it will become 0.325. Okay. Same thing. If today I have a binary number, I have 1, 1, 1, 1, 0, 1, 1, 1, like this, right? And then I have a binary point over here, right? If I multiply by 2, then I'm moving this over here. If I multiply by divided by 2, I'll move the binary point over here. Okay, and then let's look at the decimal system first. Let's look at the decimal system over here. So what really is a decimal number? I have 356, right? And then this one actually is what? Of weight 1. This one's of weight 10. This one's of weight 2 to the power 2, or 100. So it really is 300 times 10 times 100 times plus 5 times 10 plus 1, right? That's the number it actually represents by putting the 3, 5, 6 together. It would be something like this. Is that okay? Is that okay?
Yeah.
So today, if I actually say for this 356, okay. So if I have a 356, it actually is a 3. Let me put it this way. I have 356, and then this is 10 to the power 10. This one. This one actually 1, right? If I divide it by 10, it will become like this. And the weight over here is 1/10, right? If I further divide by 10, it will be something like this. Here we have 100s, right? And then if I actually, for this one, if I multiply by 10, it will be 10 to the power 3. It will give you 356, 3,560, something like that. So the number when we multiply by the base, actually is shifting. So the base number is like this. It's shifting with different decimal point. It is shifting. Okay, it is actually shifting. And then the scientific notation like 3.56 times 10 to the power 5. I actually tell you what, I have a 356 and originally it's over here, right? And then I have this actually 5 digit of the, I will shift this one for 5 times. So actually it's 1, 2, 3, 4, 5. So it's up to here. That's the real number represented by this one. It actually means this number. Okay, that's why we call it 14-point number. And actually it represents a real number. And it actually is a scientific notation like this. The number of shifting, number of times that you shift the number of your decimal point is over here. We call it exponent. Okay, the front part here, we call it the number, or sometimes it's called mantissa. M-A-N-T-I-S-S-A is called mantissa. So every computer use this kind of scientific notation to do it, except that it's using binary. So binary system, when we see a binary system, say we have a binary system, actually like 1101, right? So this 1101 really represent a number of weight 1, weight 2, weight 4, weight 8. So we multiply by this. This number actually represent 1 plus 0 plus 4 plus 8. This one represents 13. Is that okay? Is that okay? So far, okay?
Yeah.
If you have question, let me know, okay?
Okay.
Okay, now let me teach you how to convert. Let me teach you how to convert from binary. Not binary. From decimal to binary. Say I have a number 25, right? I have 25 is actually 2 times 10 plus 5, right? 2 by 10 plus 5, okay? 2 times 10 plus 5. And this one I want to convert it to binary. So I divide it by 2. I got 12, remainder 1, right? And then I divide it by 2. I got 6, remainder 0. I got divided by 2. I got 3, remainder 0. Right? And I divided by 2. I got 1, remainder 1. And then I read from here to here, it's 1, 1, 0, 0, 1. That give you 25. Binary number for 25. Is that okay? Any question about this?
Oh, why would it be 11001? Wouldn't it be 1001 or?
You read it from here to here, okay?
Oh, okay. Oh, okay. I see.
From the bottom. So every time you put your this one is what? The quotient here, remainder over here. Quotient here, remainder here. Quotient here, remainder here. Quotient here, remainder here. Is that okay?
Yeah.
And then you will end up with 11001, okay? And let me clean. Now I have 11001, right? This one's weight is 1, this one's weight is 2, 4, 8, and 16. So you end up 1 plus 0 plus 0 plus 8 plus 15. So this is 24 plus this one, 1. So it equal to 25. Is that okay?
Yeah.
Yeah.
That equals 25. And actually, 25 can also be written down by 1 time 2, 1 time 2 to the power 4 plus 1 time 2 to the power 3 plus 0 times 2 to the power 2 plus 0 times 2 to the power 1 plus 1. times 2 to the power 0. So that coefficient give you 1, 1, 0, 0, 1. 1, 1, 0, 0, 1, give you 25. Is that okay? So the binary system and the decimal system, the only difference is here I use 2. That's called binary. If I use 10, that's actually decimal system. Is that okay?
Yeah.
Okay. Now let's go back to our slides. So that's the different number system we have. And here we have the floating point number. And this floating point number say it's actually shipped by -3. So let's look at this one. You got this one as 0.9876, right? Decimal point go 1, 2, 3, 0, 0, 0 point. So it's actually 0.0009876. That's the real number this one represent for. So there's a sign, and then this one's called mantissa, second one called mantissa, and then the last one is base, sign or exponent and exponent. Is that okay? That's a so-called floating point number. And such a floating point number is stored in your computer whenever you do mathematical calculation. So real number not always countable. Most real number are not countable. So and then and if you are actually talking about English, some of the term or quantity that you can count, say 2 cars, you can put S on. That's actually countable number, countable material. Okay, so something like water, you cannot say 1 water or 2 water, right? That actually use the real number, and that you get like 2.35 liter of water, right? But you cannot count 1 water, 2 water, 3 water. And real number is for those continuous number. So for real number, you will have not be countable. Real number cannot be wrong, will have wrong or problem. Real number are conceptually continuous. Real number will have fractional parts for most of the time, but not always. So here, let's look at the decimal. We can have a equals 3.5, a divided by 2 become this, and this. Okay, let's go to our Python. Let's go to our idle. I need this idle over here. Okay. So in the idle, we can have 3.5 divided by 2. Okay, that's 1.75. Okay, and then you can a equals 3.5, and b equals 2. Okay, a divided by b, right? C equals a divided by b. I'm sorry, I assign C equals C divided by B, and then I can print C, something like this. These are the operations for floating point number, okay? These are that would be simple, and you can practice on it, okay? And then you can take square root by SQRT, so you can do SQRT of C that takes square root of C. Oh, I need to do math.sqrt of C. Now I need to import math because maths are not here, so I do math.sqrt of C. Okay, then I get it. Okay, I forget to import the math. Math is a library. Somebody write a program of taking square root for me. Okay, but I did not import it, so you will create trouble. So that's the square root. So this square root of 2 actually calculate square root of 2 for you. Okay, let me go back to PyCharm. So here I try to use idle, but now I first time use this PyCharm. So PyCharm I can actually say, let me open a directory that I have these numbers over here. I can open the file, and I open a new window. So here is a Python. So now I new a Python file. So I try example 1, okay? And then this is example 1 right here. I can say import mass. If I don't have import mass, I cannot get the SQRT program. So here,
what am I supposed to open?
What?
What am I supposed to open? Python.
Python.
File, and then.
Yeah, right now you can actually follow me on the video. You can practice later when we finish, and you can try it at home, okay? So right now you just follow me, okay? So here I can give you like mass square root 2. I copy of this. You don't need to do side by side. You can do it later after we finish, and I will give you the video and you can practice, okay? So I have this mass square root square of 2 and 3, and I run it. I'll get square root of 2. That is actually 1.414. Square root of 3 is 1.732. Okay, but if you don't like this font, then go to your setter, and then you actually can try to tune font. I can tune to 24. Okay, so it will be way bigger. Okay, so if you this will be give you a bigger font. Okay, so this actually taking square root for you and then calculate some sort of the irregular number for us. Okay, so the number set we have the rational, and the and that is different number, and that can be represented by 14 points. But because here we have limited number of the digit, so in fact all the 14-point number are actually rational number. They are not really irrational number because we have limited the number of digits. So that actually is a simulation for the real number. The square root is actually not the exact number for square root 2. Okay, and then the next one you can do type. For example, you can check the type. So let's go to let me use idle. So for example, I can actually right here, I can actually do type of this C. It actually is a 14-point number. And if I do type of A, that actually is a 14-point number as well. If I say type of B, that is actually an integer. Is that okay? So integer is actually countable, 14 point is not countable. Okay, those are different. And in the future, I'm going to teach you how to count for more time. So these are getting type. If you don't know what type it is, actually using the type with the number available, it will tell you. Okay, as a type conversion. And also you can, if you put type, it will actually get this. If you actually put type, that will give you conversion. But this conversion actually converted 3 because it actually truncate everything. So right here, I would like to actually talk about this. Okay, so if I have this, actually, I have an integer of 3.0 or 3.2, that will should give you 3. But if I do floor or 3.2, that will give you 3. I'm sorry, I should do mass. Let me see. I should import mass. Okay, and then I do floor or 3.2. Wait, I should do mass.floor 3.2. Okay, that give you 3. But if I do mass of ceiling, that will give you 4. So what happened is the ceiling function and the ceiling function and the floor function are different. So when we have this conversion from integer to floating point or floating point to to integer. It actually use the int function. You put the utility floating point there, you will convert into some integer. And if you do float of integer over there, you will convert to 14-point number. So that here, right here, if we do int, it will be truncating the number. So it actually from 0 to 1, you will get 0. So this is x, this is y. From 1 to 2, you will get 1. From 2 to 3, you get 2. This one is called floor function, or sometimes we call it the truncation. I'm sorry. T-R-U-N, truncation. Okay? And the int function is actually doing floor function. Okay? And there is another function called ceiling function. Ceiling function is different. Ceiling function is 0 not included, and then after that, actually 0 not included. 0 is actually 0, but from 0 to 1, you actually got 1. And from 1 to 2, you got 2. This one is called ceiling function. Okay, like your house. You have a house, right? And then there's a floor that's under the integer under you, and you have ceiling. And ceiling is the number above you. Okay? And int function actually is the same with floor function. Okay? That's some basic function. And then that is a type conversion. You can convert from one type to different type. Okay? You convert from one type to different type. Now this one is a fractional number. Okay, fractional number need to call a module called fractional. Okay, that square root I need to call mass, but there is another one called fractional. And in Python, there are 25 different type of the module. And we have the NumPy, SciPy, scikit-learn, pandas, Pedo. All of these, if you install the SciPy package, it will come in to help you, okay? And we will later we'll talk about that. And here we have a fractional number. A fractional number is a number represented by A divided by B. So this is two integer represented, okay? Two integer represented. So a finite digit is actually like this, 355. So basically any of the decimal number, finite digit decimal number, it actually can convert to a fractional number. Okay, is that okay? So it means like 1 divided by 7, that's a fractional number, right? And then if you have 0.25, that actually is also 25 divided by 100. So that's also a fractional number, right? So all decimal number can limited number of digit fractional number can be converted to fractional number. But if something that actually repeat, that can still be a fractional number. For this one, it actually is like 3 plus 5 over 9. So that gives you 9, 27, 32 divided by 9. Okay, that is actually this number. So that's the fractional number. And fractional number in Python, you would have this, you have to call this a fractional number, and then that would give you a fractional number. So this one actually, this one 16 and minus 10, that give you 16 over minus 10, that actually minus 16 over 10. And this one fractional number 1, 2, 3, that is actually give you 123 over 1. Okay, and this one, if you put a single quote, 3 divided by 7, this one is called string or text. Okay, We talk about numbers so far, but we haven't talked about what is string. Let me show you what is string. It's actually text message. It's another kind of data. It's another kind of data we would use. So let's bring up this for this Python this idle. So actually I can actually do print and then single quote, welcome to Python programming. And when I print this, it will give you the text, welcome to Python programming. Okay. And what's that for? What's that for? That is for sometimes we do programming, right? And then we need to have some text. So let me bring up this example 2. So something like if I want to do this, print welcome to Python. So this you have the underline red over there. That means that it actually is not recognized as a string. So I need to use a single quote. That's fine. Or if I do this, I have a double quote and then welcome. This one is also a text string. Okay. This one is also a text string. Text string is not number. It just show you the message. Okay, now I do this. Okay, I do this, enter your name, something like that. And then here, I would say actually xz equals input. And then like that. And then I print z. Okay, I just do this. Here, I just run it. So it's like, welcome to Python, dot, dot, dot. And then here, it say enter your name. And then after that, it say input. So here, I actually input my name. Okay, hit return. And then you see another print that actually print out this one, my name. Actually, that is also a string. So here we have 1, 2, 3, 4 different strings. Okay, the first two, if you use a single quote, you use a single quote, and then inside here, like is ABC. This is one string, okay, or text. And text is called string, string in Python. And double quote is also a string. Two have no difference, okay, single quote, double quote have no difference. And you can use that to show your message, okay? You can use that to show your message. And these are actually the way we print out text, okay? Even if you actually do this, print double quote this slash u, right? I keep it here. And right here, I come to here, and I actually type. Okay, I try to get the Unicode, and then here is 5468. So I come back here, I put 5468, okay? And then I run. And here I put this. Okay, so even a international letters like Chinese letter can also be printed. Okay, so that's actually the text message. Is that okay? So that's another type of data called string. But right here we have this fractional number. So let's try this fractional number now. So here we have a fractional number. And let's put it as an exercise 3, okay? And here I need to do import and fraction. I'm sorry, I should do from in fractions, import capital fractions, okay? And then I say A equals fraction of 1/2, okay? B equals fraction of 1/3. And then 1/2 plus 1/3 would be, putting out A plus B, that would be what? That would be 5/6, right? And then we print A times B, that would be 1/6. And then we print now A divided by B, A divided by B, 1/2 divided by 1/3, that actually is 3/2, okay? Print out A minus B. 1/2 minus 1/3 would be 1/6, okay? Now, actually, let me run this exercise 3. Is that okay? So this show you how fractional number work, okay? So you need to do this from fraction, import, whatever. This one, we call it module. Okay? And for module, I can do from fractions, import fraction. So the fraction class or the definition of fraction being imported in. So I can actually do this addition, something like that. But if I don't do this, I just do import fractions instead of from fractions, import fraction. Now this one fraction is illegal. It has a red over there. But in order to do it, actually I would do fractions dot fraction, fractions dot fraction, and it will find a module. Is that okay? And then I do running. The two actually work the same way. Okay? So this one actually, without from, if you do from fraction, import fraction, you don't need to put this here. But if you do import fraction, now you would do need a name before it. Okay? This one is porting, but without creating the namespace. But that one actually creating the namespace. And creating a namespace, open the namespace actually sometimes easier to use, sometimes will have conflict for a basic definition. But in this case, actually, from fraction, import fraction would be better than this one. So I would rather use that one. I would rather use this one. That would be easier. Okay, and that actually give you some sort of the function you can use. So in learning Python, you are basically learning the language, and also you need to learn about a lot of different libraries. Is that okay? So now if we, let's go back to our fractional number. So that's the fractional number we have. So here you can try different fractional number later by yourself, okay? Here you can try this different fractional number by over here. Now, my question is, given 66 divided by 3, what will be the result for repeating the digits? Why the result will repeat the digit? And then why this guy 66 divided by 5 will not repeat the digit? Why? Why 66 divided by 7 will repeat the digit, but 66 divided by 5 will not repeat the digit? That's because your 66 divided by 5, you can actually easily times 2 on the numerator and denominator. That will give you 132 divided by 10. Then this is actually in decimal system. That will be 1.32. Okay, but this one you divide by 7, you will never get the you will never get any clean division. So actually you will repeat. that guy will actually repeat. Okay, that guy actually will repeat. Okay, so let me show you. So for example, if I have this one, 10 divided by 7, right? And it will be 1, 7, and then it was 3, 0, right? After that, you have 2, you have 4, 28, and then 20, and then you have 2, you will have 14, and then you have 6, something, right? So actually, you will end up repeating like that. I'm sorry. It will actually repeating like that. You will have 1, 4, 2, 8, 5, 7, keep repeating. Okay, keep repeating, because every time the remainder, it will actually add another 0 from the next digit. It will keep the same 10 divided by 7, 30 divided by 7, 20 divided by 7, 40 divided by 7, 50 divided by 7, and 60 divided by 7. And all cannot resolve the digits. So it will keep repeating. Okay, it will keep repeating because of that. And under what condition the number will have the repeating digit? When your number division is not multiple of 2 or multiple of 5, you will only have a clean non-repeating number if you are divided by 2, 5, or combination of 2, 5. Okay. So why any integer divided by 10 to the power order will always end, but not 9 over actually nice order. Okay, let me show you. Okay, then now let me see later. Okay, let me give you an example. So right here, for example, I have 10 divided by 9, right? So it's actually 1 divided by 9, and then 10 is will be 1 and 9, and it will repeat it like that. So it's 1.11111 repeating. Okay, that's because your divider is not a multiple of 2 or 5. Okay. Now let's go to this convert to decimal. Let's go to this convert to decimal example. So we have convert to decimal example question. Convert to decimal. So we have 3 over 5. We put in A, and then we use that convert it to floating point. So that this one is actually a fractional number. So the fractional number can be converted to 14-point number. Fractional number keep track of 3 over 5. But once you convert it to a 14-point number, the B will become 0.6. It's no longer keeping track of the 3 and 5. But if you have that 3 and 5, you can get the numerator and denominator by this 8 dot something. If A is a fractional number, you can get the numerator and denominator like that. Okay, that's how you operate the numerator and denominator in Python. So now let's run it. Okay, so you got this. Okay, so that's how. So basically, this teach you what? This teach you when you have number, you can have like 3, 5, something like that, right? You can have 0.6, and from here to here, you use the float to convert integer into a floating point. From here to here, you actually use int or float or something to convert to integer. And then from here, you can have an integer, and then you put it here, and then you have a fractional, right? That's a fractional number. And then you can convert it to here if you use the float function, right? Something like that. And then you can actually use the fractional number constructor, put in you 3 divided by 5 with a string. That will also convert you back to a fractional number. Okay. here are actually exercising the different number system, number conversion from different format. Okay, for different format. Okay, the next one, terminating decimals. The terminating decimal, as I mentioned, it will be divided by any combination of 2 to the power n or 2 to the power m. Any n5, it will always be terminated. Say, for example, if I have some number 152 divided by 8, right? It actually can always find an 8 and then 125. 125, 8 times 125, so 152 times 125, you will end up with a number divided by 1000. So that actually can convert it to a stopping terminal decimals. Okay, that will actually stop. So any number like this, it will stop. It will actually stop. It won't repeat. Okay, no matter it's a rational number or irrational number, we all stop. Now here is a fun part. See this old guys. Okay. First, let's use Python to solve 3/2 plus 5/3. Now let's do this first. Okay. Now let's do this. Use a PyCharm. And let's bring up the PyCharm's Python console. So the you want to have 3/2, 5/3. Okay. Okay, right here. First thing I need to do, because to avoid the problem, I need to do from fraction, import fraction. Okay, and then I have a equals fraction of 3/2. I'm sorry, not 3/2, 3 and 2. Okay, I have a b of fraction 5/2, 5/3, I'm sorry. Am I correct? Am I doing the right thing? Okay. And then I hit return. And then the next thing is I want to print a plus b, right? I get like something like that. I think it's doing a better job than me. Okay, now, second one convert 22/7. Okay, 22/7. Now I have a fraction number. So let me actually, I print fraction 22/7. Oh, I'm sorry. I put it in the wrong. I should print 22 and 7. Oh, I'm sorry. I kept making a mistake. It should be fraction 22 and 7. Okay, I should actually do float. Not actually print out the number, but it's not actually what I want. I should do 22 and 7. Convert it to floating number. So that give you 3.142587, whatever. What's the number here? What is the number here? That's the fractional, that's the pi number, okay? So if I have the float, the next one is 355/113, okay? So this one, fraction of 355/113, okay? Okay, this is very close. 3.14159.2. I think it's 26. Okay, so it actually down to 1, 2, 3, 4, 5, 6, 7th digit accuracy. Okay, and the reason why I bring up this fraction number is because this number is called pi, right? And this pi ratio of 355/113 or 22/7 is discovered by this guy. in about the 5th or 6th century, okay, from China. So that this guy Zhu is actually an expert in doing that. And it actually, the original idea of calculating this ratio is because we have the orbit for the Earth, right? Our Earth is moving like this, right? And then there's a sun in the middle. Not actually in the middle, actually it's on one of the focus over there. And then he is trying to come up with a ratio of your diameter to the orbit, the circle. So it's actually calculating the ratio between this diameter and the orbit, the perimeter. And that ratio can be summarized to 355 over 1133. Okay, that's a very good estimation back in the 6th century. And European people actually have spent about another 1,000 years to catch up this number. Okay, but that's actually a very good estimate for that. And initially, as you can see over here, this number 355 is very close to 1 year. So he tried very hard to come up with a very good estimation down to the very 5 digit to represent the fractional number. So fractional number, in a way, in the ancient time, is a good way for doing estimation for the irrational number, something like pi. Okay, you can always pick up a ratio to do it. So some of the important irrational number you need to keep in mind is pi number. Okay, the epsilon number. Okay, and then you have the golden ratio. Okay, those numbers are very famous irrational numbers. Okay, can we stop here?
Okay, thank you.
Thank you. Bye now.
Bye. Bye-bye.
Thank you.